Hello, my name is Nikola Stošić and I hold a chair in Positive Displacement Compressor Technology at City University London, or better to say, at its Centre for Compressor Technology, which next year celebrates its 30 years anniversary. I will talk to you today about the operation principles of screw compressors. This is a fairly straightforward presentation which will give you basics of the screw compressor and its operation. At this slide, people see animation of a screw compressor, which housing is gray and yellowish, and the main rotor which works is presented in blue, while the gate rotor which idles around the main rotor is presented in red. We can see only two moving parts of the screw compressor, which is the main advantage of a screw compressor compared with other compressors. By definition, a screw compressor is a thermal machine which transforms mechanical work into internal energy. The internal energy is represented by a temperature increase in this process, which is in the confined space manifested by the pressure rise. This is the main duty of any compressor, which is to increase pressure. A screw compressor contains only two moving parts, which are presented in this slide. A red housing contains the rotors, the main and the gate rotor, which rotational movement defines the volume change, which is presented in the animation. The animation shows the rotating rotors and the pressure within the volume they define in different colors. The suction pressure, the lowest pressure at the largest volume, is the blue. The pressure changes color during compression from blue to light blue and green to yellow and red as the discharge, which is position of the highest pressure. And the lowest and highest volumes are determined by the ports which are given at the right bottom part of this slide. The left rotors show the large suction port, which contains the largest volume. The right rotors show the discharge port, which is small, indicating that the volume closed by the discharge port is small. Thus, as a result, we have a change of volume, which results in a rise of pressure. And in a nutshell, this is the basic principle of the screw compressor operation. In this slide, we can see animation which shows operation of a screw compressor in different projections. Since the rotors only rotate because the machine has no reciprocating parts, it can rotate fast. Then, if we look into the animation carefully, we will see that the gas flow is more or less straight, allowing high shaft speeds and high flow of a relatively small machine compared with other compressors. There are no valves in that machine, which means that all troubles connected with the valves will be avoided. The process itself starts with the suction volume, which is now presented in red. Then gas goes through the volume reduction, and after the volume is reduced, it is discharged once the discharge port is open. How this happens, we can see in the volume and pressure diagrams. The lower diagram shows the volume changes when the volume is increasing to its maximum when the suction port is closed. Then it is being reduced, which causes pressure to rise until the discharge port is open, and as a result the pressure will change from the lowest pressure to the highest at its discharge. The main application of screw compressor is in the air compression, refrigeration and process gas compression. The main industries which use screw compressors are building industry, oil and chemical, food and pharmaceutical industry, as well as power generation. Two main modes of operation of screw compressors are oil-free and oil-flooded, which representatives are in this slide. When the oil is injected between the rotors, it serves to lubricate them and seal gaps between the rotors, as well as to cool gas which is being compressed. However, as a result, the gas is contaminated by oil, which needs to be separated from it. This, regardless high level of separation, is not sufficient in food and pharmaceutical industry, where oil-free compressors with synchronizing gears and rotor seals have to be used. Due to high pressure forces acting upon the screw compressor rotors, high number of strong bearings needs to be used. 9 in total in the compressor presented on the left. Since the working chamber of the dry screw compressor presented right needs to be separated from the gears and the bearings, otherwise lubricated by oil, 8 seals need to be utilized, all at satisfaction of the bearing and seal industry. Number of dry compressors is relatively low in the screw compressor population, which is today counted in millions, not more than 5%. However, due to their large size and high manufacturing cost, their share of the screw compressor market is relatively high. Screw compressor lifespan, due to the low wear and high reliability, is relatively long, years and even 10 of years, which results in a higher number of screw compressors in operation, regardless they are not large production, which is only several hundreds of thousands in 1 year. This slide shows what the position of screw compressors is in the compressor world, which is medium flow and medium pressure ratio. They compress between 1 and 1000 cubic meters per minute gas with pressure ratio up to 3.5 in the dry and up to 20 in the oil-flooded compressors. Thank you for watching. With that, we conclude today's short lecture. For any further discussion and questions, please get in touch. If you wish to get more information about the screw compressors, please don't hesitate to visit our website, which link is presented in this slide, together with our email address.